Thanks for coming. My name is Ryan. I'm one of the product managers on Unreal Engine. And we're here today to talk about in-camera visual effects with Unreal Engine. So first off, quick show of hands. How many people went to the user group event on Monday? So many people. So I'm just going to re-show the video. It kind of sets the stage for a lot of the, or basically this kind of scope of work. And also, just to make sure everybody has seen it, because we work really hard on it. So here we go.
Great, let's cut and reset.
No matter what the project is, the creatives always want to see the closest representation to the final product as early on in the creative process.
When I first walked on the set and the wall was up and we started to look through the camera, it really started to feel like I was just filming in this actual location.
We can track a camera's position in space in real time and render its perspective so that we can compellingly convince a camera that something else is happening in front of it that really isn't there.
The thing to keep in mind is that the 3D world that you see on the wall is also a 3D scene that you can manipulate in Unreal Engine. So this gives the filmmakers full flexibility to make any change they want to the scene live.
So it's really exciting to see that we can, use the real-time lighting to not only change the environments virtually, but also have it affect the on-set lighting as well. This opens up kind of like a virtual playground to shoot in.
With VR Scout, you have your department heads collaboratively going into the world together. They're able to make decisions that inform the creative process down the road. It gets them more grounded into the scene that they're shooting, into the story they're trying to tell.
Because you can interactively change the world, it brings all of those departments together because each one of them has a role in how this world is portrayed at some point along in the production.
The director and the DP, they're back, and they're now able to work directly with the teams in real time. It's a really exciting creative process to be part of.
So yeah, you might have been watching that and been like, that's pretty cool. Looks pretty easy, right? Like, how hard could it be? Just like, step one, build a wall, right? Look how fast. Like, this doesn't take any time at all. They move really, really fast. The wall just goes up. Step two, just get a nice environment like this one from the Quixel team. Looks pretty good, looks pretty real, right? And then like, last step, point the camera at the wall and shoot some stuff, right? It's like final, right? It's just party. We're good. Nailed it. Yeah, so turns out there's a little bit more to that. Otherwise, that would be like the end of the talk. And I would have stayed up all night on this talk for no reason. But we're here to help. And that is actually what the rest of the talk is about. You can still give yourself a high five at the end. Like I will. That's for sure. So yeah, this talk kind of centers around a project that we've been working on and is starting to roll out that was sort of what the video, like the making of, that making of video that we showed was the genesis of this project. It's a big collaboration between all of the companies you see up there. They're people that we've worked with on a lot of previous projects. It's kind of like this sort of Voltron to a virtual production to try to build out all these workflows, figure things out and democratize these tools so that they're just available in UE4 and available to everybody in the audience to try out for themselves. So we're going to kind of focus more on the specific LED wall shoot aspects of it, but I did want to quickly highlight the Magnopus team. We work really closely with the Magnopus team on VR scouting. So there's a suite of VR scouting tools that is coming in 4.23, which is releasing next month. And then there's a second wave of it coming in 4.24. And we really focused on providing filmmaker-friendly UI and UX for exploring the scene, collaborating in VR. And Magnopus brings a lot of expertise to the table in this area that we're trying to leverage and include to improve in the product. And then on the Quixel side, our demo scene is from Quixel, uses their kind of Megascans library of all these great looking photogrammetry assets. I'm always blown away by their work. We kind of want to point people to this training piece. So it was given by this guy, Galen. Galen worked with us actually on stage, like tuning the environment. And it's a really, really informative training piece. It's like its own talk, so I encourage you to watch this video. But sort of getting back to the shoot aspect, there's kind of three key components here. Like there's the camera tracking aspect. So we're live tracking the camera, like where it is in space, what lens it is, essentially what it's supposed to be seeing. There's the LED wall, and then there's Unreal Engine itself. Right? So the live camera tracking essentially lets the background do what it's supposed to. We render we render the lens field of view so that anywhere you move it, you get this like sort of real parallax. So when you move side to side, the parallax happens, and you'll see like a shift. You'll see extra depth when Matt, the DP, is kind of like moving the camera back and forth and panning. Right. So this is more than just a flat video wall. Like there's been a number of pieces out there where they are showing a flat video wall. Like a lot of those shots look great, but we feel like this addition of live camera tracking adds quite a lot to the experience. And then similarly, like on this sort of wider shot, we're both booming up and dollying in. So you can see, like when you boom up, like the horizon shift, and then as we dolly in, like what the lens is actually seeing in relation to the wall is, it's sort of becoming more of a picture-in-picture within the wall. So essentially, like what is inside of the camera view is the thing that's always moving, and then what's outside is static. And the reason for that is because we're using that static outer capture to add like real-world reflections and lighting. So this video is a little bit better example where we have the camera pointed on the actor, and he's moving the camera around, but in this case, like the camera is definitely not seeing that sidewall. And you can see that no matter how he moves the camera, it's always static right there, because in a nutshell, you don't really want moving reflections or moving lighting, because that's not what would happen in the real world if you were just sitting there. And the end result is like a shot like this, which we sort of staged to showcase the reflections. But you get this nice, you just get nice looking real reflections. That's sort of all there is to it. So that's kind of like the three main components. And then on the Unreal Engine side, we have all of these different stakeholders interacting with one another, and that all kind of comes together with the multi-user editor. So this is a feature that we've added and worked on over the last couple releases, and we really see it as like the core of our virtual production like tool set. It's the thing that lets sort of as Matt Madden was saying, like all the different parties working together. Like they're all technically speaking likely to be on their own machine, and all of those things need to interact with one another, all in the same scene. So they're all talking to each other, and any modifications they're making get communicated out, and that's all through the multi-user editor feature. I should also add that Live Link helps a lot too. We're going to now go through we're sort of going to go through the difference between those two things, but in a nutshell, like multi-user and Live Link are how we sort of take all this data that's happening and changes that are happening on set and fold them all together into one. So starting to get more specific, like on our particular shoot, we ended up having like essentially 8 machines that we needed to track or were doing stuff of interest. So that's all kind of centralized through multi-user, but sort of in our kind of pyramid of machines on set, there was the profile machine, right? So this is where the camera tracking data is going to. So Profile's got a system that can live track the camera, and that data comes through essentially their server that then broadcasts it out to everybody else. We have the primary Unreal Engine machine, and this is sort of what the stage operator is on, right? So any modifications that we're making live on set, if we're recording and take recorder, like all of that's happening on the primary box. Then we have 3 render boxes. So these 3 render boxes are the things that actually put pixels on the wall. So we're going to kind of go into each one of these sections in more depth, but this is sort of setting the stage for all the different parts. There's another machine that's doing a live comp. Potentially optional, but if you are maybe going to have some green screen shots, you may also want to do a live comp, and so that's kind of its own station. And then last but not least are the VR Scout machines. And in our case, we had 2, so 2 people could be doing scouts. Obviously, you could have n number of these things if you had a whole bunch of people collaborating. The people might be doing set dressing. They may just be watching what's going on in the scene. Maybe they're prepping, planning shots that they're going to shoot next while other shooting is happening. The point is that all these things can be happening at once, all in the same scene live. So we'll start with Profile at the top. So this is a quick video of some of Profile's work, right? So Profile has like a mix of like in-house and third-party tools that they use to prep things, and this is them kind of setting up their camera for the day. When that data is transmitted to Unreal Engine, you'll get something like this, right? So you can see in the background, we kind of go back and forth here, but Matt Workman is moving the camera around, he's moving it up, he's moving it back down, and so as he moves it back down, we'll kind of rack focus back on the UE4 screen. You can see the camera's moving. And this is just to show that like anything that is happening in the real world of the camera is being reflected live in Unreal Engine. And so this is a live camera, and this, as a result, we can do a live render based on that camera. Few things to note about LiveLink, just specific to plugging 423. So in 423, LiveLink got an upgrade. It now has this concept of roles. So that kind of helps you manage the different types of data that are coming in. In this case, like Profile's stuff is all coming in as animation. They do a bunch of mocap work as well. So they're like it's simpler for them to keep it all consistent. But you can create other roles. Like the main one that we're seeing is tracking. So there's a lot of different camera tracking providers, and so this is kind of making it easier for them to stream in their camera tracking data, like for folks like NCAM, MoSys, et cetera. We also have this concept of presets, right? So presets just make it easier to manage like all of these different settings, which of which there are many that can be easy to screw up. Oftentimes you have different settings even for the same provider. So in our case, we had a different LiveLink setup when we were doing live comp with Composure than we did when we were for our standard preset. So that's why we have two up there. We just have the main profile one, and that's what was used for the wall, and then we have a separate one for Composure. So next we'll try to kind of make this distinction between what LiveLink is for and what we use multi-user for. This is actually kind of a little bit of a puzzle, so I hope this diagram reads. But they're kind of two concepts that have strengths and weaknesses, and depending on the use case, you want to use one versus the other. So we'll start with LiveLink. So the approach to LiveLink is it's a multicast workflow. So Profile takes in the tracking stream, and they basically broadcast it out to all of the other machines that are interested in the camera data. So that means it goes out, and we're just streaming it out to all the different machines. The idea here is that you want to use LiveLink for things that have like rapid, high-volume transactions, like frame-to-frame camera tracking data. Like Profile actually sends us like 4 pieces of info for every frame. And then the distinction to note is that with the nDisplay render machines, like we also have to keep in mind that the different machines rendering the images to the wall also need to stay in sync, and so our approach to that is more of like a master-slave style relationship. So in our case, we sort of designate the first render box as the master, and so like that's the only one that gets the LiveLink data, and then it's the responsibility of the first render machine to tell the others, and that's how we make sure that all the rendering machines are in sync. This is like sort of contrast with the multi-user editor. So this is like a different approach. Like it's not necessarily as live or as the LiveLink approach, right? So there could be a little bit more delay. But the advantage to this is that it's a more robust, like sort of collaboration mechanism, and it supports more like anything that you're going to potentially change in the editor. You don't have to do anything special. You're just working in the editor as normal, and it's just being sort of broadcast to everybody else. And so this one is more of a client-server model. So we have a multi-user server that we start up, and then all the different machines connect to it, right? So all of the UE4 machines connect to it, and then we sort of still have the same concept here where the main render box connects to the multi-user session, and that's receiving any change, right? So if somebody on the primary box maybe increases the exposure or moves something around, or maybe somebody in the VR, maybe it's more likely that somebody in VR scouting is dressing, maybe they move some rocks or they move like a prop around, like that gets sort of sent to all the other machines through the multi-user feature, and that's also how it would be reflected on the wall. This is like kind of a slight pivot here to like more of a pipeline chat, but as you can see, like this is a lot of machines, right? Like it's a lot of stuff to manage to actually make this happen. So we've invested in some tools to do that, just because if you really think about it, every time you needed to start this up, or maybe something happened, or even if you just had to do this once a day, like starting up all of these things and setting them up, it's kind of a pain in the ass, right? So you'd start out maybe, right, and nothing's on, right? So here you are, you're starting out, you're like, here I am, let's get this started. So first thing you do is you like light up the multi-user server, you're like, cool, multi-user's up. Then you go to your first machine, the primary, so you turn that on, connect it. And at this point, you might be thinking like, hey, this is like, I still have a lot more of these to go, right? So you keep going. Got render, you're like, everybody's waiting on me. Got the comp, everybody's mad. People blow up, and then at the end, like, it took so long, everybody's asleep, like, can't shoot. So to get around that, we invested in this is a pretty basic PySide app here, which we just call the stage control app. But the key here is that it's a big launcher, right? So it knows how to launch all the machines. It does all of the different maintenance and management to lighting up a session and turning it off. So at the top here, this is how you connect all the different machines. There's a way to define all the different machines. There's a space here to say which scene you want to open, right? So our model for managing scenes on the wall is that you basically use the launcher to launch a specific scene, and then you sort of bring it down and bring it back up, and that way you can make changes on the fly much faster, or if there's a problem, it's very easy to start it back up again. We kind of emphasized that route because it's new tech, and we thought there might be issues with the scene going down, and now we've come to realize that that's actually just a really nice approach to bringing stuff up, bringing it down. It's very clear what's happening, and you always know that you're starting up from like a clean session. And then sort of on the side, you can define like all the different machines that you have. So these are all the guys that we had on stage. There's also some other permutations that we've started to find like as we got into more of a production rhythm, where sometimes people would drop out, sometimes people would drop in. They'd be doing their own stuff. So the control app kind of lets you maintain that. You can drop people out, you can bring them back in. It's worked pretty well. I have to say that like this was when we were going into this production cycle. It was a little bit of an afterthought, but like this app was like really important. I actually can't imagine doing the shoots efficiently without it. So yeah, pipeline tools. Pipeline tools are good, I guess, is the takeaway. All right, so nDisplay. nDisplay is a feature in Unreal Engine that it kind of comes from the live events projector space. Like a lot of cave setups are done using nDisplay, and now it's been extended to kind of work with this LED wall shoot workflow. And so the idea here is that it's a scalable rendering setup for multiple displays. You can have as many displays as you want. So potentially an LED wall can be as big as you want. You just need more machines, right? So depending on how big it is, you just get more machines. You buy more graphics cards from Rick. And that's the idea here. So bring it back to the kind of camera tracking aspect, and the in-frustum versus out-of-frustum. Like a couple things to note about the feature set. First off is that we've designed it so that you can get the highest possible resolution, like in-frustum. So most of the graphics hardware and the setup as a whole is set up to sort of emphasize that the frustum is always as big as it can be. Like typically that's at least 3K or 4K. You also have the ability to reduce the resolution outside of the camera to preserve scene performance. Like again, like you're never seeing what's not in the camera. It's just there for lighting and reflections. So oftentimes you'll run that at like half res or lower res just to save performance and really make sure that the in-frustum is the highest possible resolution you can get. And then we've also got support for curved LED walls. So we're going to get into a little bit more of the details on that, but that was another feature add that came with this round. As mentioned earlier in the diagram, there were 3 render machines, right? So this is a little mock-up we did just to show which machines were on which sections of the wall. So there were, again, 3 machines. So render 1 was the left wall and the left side of the front wall. Render 2 was the right side of the front wall and the right wall. And then render 3 was the ceiling tile, or the ceiling wall. And so sort of to put it all together, they're all 4K outputs. As a total, there were around 12 million total pixels. And so like nDisplay is a little bit tricky to set up. So we're going to go through a few slides here to kind of guide you through those steps and show off some of the new features that allow this setup to go in. All right, so first step is to enable the nDisplay plugin. This has been around for a bit, but obviously you're going to have to enable this guy. Second is this new plugin, right? So the nDisplay team have added this additional plugin called Warp Utils, and this is what's used to generate the data that actually drives the mapping of the wall. So when they're kind of putting this together, they were talking about their PFM-based approach. I work remote from the rest of the team in LA, and so like they were going over this on a call, and I was like trying to play it cool, but in the meantime, I was just Googling like what is a PFM file. So a little bit of background on the PFM file. So PFM stands for point float map, but I believe it can also stand for pixel float map, but we call it point float map for what it's worth. It's basically a mesh of the screen. So each vertex in the mesh corresponds to a pixel in the LED, so it's like a really dense mesh. And the idea here is that this produces like the best quality when they do the mapping. Most LED walls have the same nature. There's a bunch of different ways to generate the PFMs. This is kind of going through the golden path, or what I think is the easiest to understand, right? So, when you're building a wall, like you're likely to have all of the same panels. Most of them are going to have at least the same nature, right? So it's typically tiles of the same size and resolution. So part of the plugin setup that nDisplay offers, it has like a procedural generation setup for configuring the wall. So in this case, our panels were 50 centimeters by 50 centimeters, and so this is important information to remember for the next steps. Once that plugin's enabled, like some additional blueprint classes will be created, and this is going to kind of guide you through this like step-by-step process. So the first step is to create an LED tile blueprint. So you can create that, you can name it, and then when you open it up, there are parameters in it for you to define essentially the size of the tile. So we measured it before, and they were 50 centimeters by 50 centimeters. And then pixel-wise, they're 176 by 176. This is information that you would just get from like whoever you bought the tiles from. So once you've defined your tile, the next step is to like sort of construct a wall based on those tiles. So for that, there's another blueprint you create, which is the LED wall blueprint. It's kind of same setup, create it, name it. And it's got its own settings, which are pretty straightforward, right? So you're going to define the type of tile that you're using. Like oftentimes on a stage, you may have like different types of tiles for different sections of the wall. Like for our wall in our shoot, we had two different types of tiles. We had a certain type that was used for the front curved and the side, and then we had a different setup for the ceiling because the ceiling tiles needed to be lighter in order to be hung from the ceiling without sort of dropping on us. These are kind of some of the nuances to putting these shoots together, which has been pretty interesting. But the idea here is that we can support that. So you can define it assumes that like each wall has a certain type of tile. So we define all of those walls separately and differently. And in this case, we're mapping the front curved wall. So that one was 18 by 17. And you can also tell it an angle. So in our case, the angle was 3.5 degrees. So the curvature of it was 3.5 degrees. So you fire those in, set those up, and you're pretty much good to go there. Next up is to drag it into the scene. This is basically to place it into the world, right? So you're setting up a scene in UE4 that establishes like where the stage walls are. So you drag that in. You're going to want to set it to the top left coordinate. Like so, when we set up the wall, you're placing the point in the top left. And then if you hit the build button, it acts as a preview. So that when you hit build, it's going to sort of show you where the wall is. You can then continue to move it around to place it in the right spot. And then the next step is to give it an origin. So the origin is kind of what maps like all of the walls together. So in this case, in this demo, I'm only going to show one. But if you had multiple, like they all sort of need to know where they are relative to one another. And that's what the origin is for. So you can pull that guy out. You can pull it out of the Warp Utils plugin content. You just got to drag that guy in there and place it and position it to a known place. One thing to note is that it is like we generally suggest that it's a best practice to keep it the same as your camera tracking origin. So that way, like zero, essentially like 0 is 0 for both the live camera track and the stage wall space. Eventually, those are going to have to be kind of married together, so it just makes sense to keep them consistent in that way. Otherwise, you're going to have to chase an offset all of the time. You can use the offset, and we actually tried it. At this point, I would really strongly recommend that you keep them the same. It just makes your life a lot easier. All right, so I kind of wish I had cut these down a little bit, but but we're kind of in the home stretch here. So now you're ready to generate this PFM file. You give it a path, you tell it what the origin is, you select the wall and generate it, and that gives you this file. So now you're set on the PFMs, and the last step is to like bring the camera into the mix, right? So you're going to need to bring in a cine camera, and then basically also add this reprojection camera, which comes from the nDisplay content, and you just got to marry those two guys up. So you basically need to tell the nDisplay camera what the Unreal camera is that you're going to use, and also note this viewport ID, because that's what you're going to use later to map the in-frustum setup. Last but not least, it's another best practice to kind of include it in your hierarchy. So in the outliner, you'll have like this kind of like tree of cameras. That's like the Unreal camera, the camera you get from the camera track, and then also this guy. So you're generally going to want to keep them together. That's my advice to you. So the last step to configuring nDisplay is the nDisplay config file. This is a big spaghetti soup of text. We're going to go through it a bit by bit because I was always really intimidated by this thing, but over the past week I've come to understand it much better. So I'm sharing that with you now. So if you go by section by section, it's actually quite hierarchical. So first step is you define a cluster node. A cluster node is a render machine. Very straightforward. You're basically just giving the IPs for the 3 boxes that we've established having, right? A window defines views for each node. So we render the inner camera on each node. So this basically means that like if you pan the camera and the in-camera view is on any of the walls like that, it will show up. And then this is also defining what we were describing earlier. So render machine 1 is on the left and the left side and the front left, and then render 2 is on front right, rights. This is where you make that definition. You always want to be in full screen. This is a really long story, but just always stay in full screen. Like really bad things happen if you don't have this full screen thing on. Rick was on the email thread about that, I think. All right, so viewport dictates which pixels go where. This is something that like you'll typically work with the people who manage the wall. It basically just comes from the LED processors. It's part of the interplay. You only have to set this up once, but it goes into the mapping. And then last but not least here is the projection, right? So the projection knows where to get the data and how to use it. And this is where you kind of tie in this PFM definition of like where your walls are, and then it kind of ties together with what the camera is supposed to be. So you're telling it where all these things are, and this is what lets nDisplay know how to map like the data from the PFM to the data that it's going to render. MPCDI just means it's a PFM-based mapping. All right, I think I got through that part. We're going to switch gears a little bit and just talk a little bit about scene organization. So this is another thing that we've been iterating on, and it's something that we'll keep working on with productions. But like all of the stuff I just went through, it all talks about like how you set up the stage content, right? So where are the walls? Where is the camera? There's a whole bunch of stuff that you're always going to kind of have set up in the scene. But at the same time, if you're doing like a higher volume like LED wall shoot, you're likely going to have a whole bunch of different environments. And so the way we do that is to separate all of the stage stuff out into like a stage level. And so like that's separate from the actual content. So the idea is that you can have a stage level that's like always got the stage stuff set up, and then you can kind of keep it together with just by subbing in different environments in. Otherwise, you have to keep duplicating all the stage stuff. So this has worked pretty well for us. but it's something that we're going to keep thinking about and try to make easier to manage for the content side of things. And there's some balance there between the two. And then another tip here is that the team wanted me to pass along is that you do always need to set all of the levels to loaded, and that's like a multi-user feature. So if you don't have them all loaded, then the multi-user changes won't be transacted properly. All right, so Genlock is the next topic, right? So Genlock is basically how we make sure the camera, the walls, and Unreal Engine are all in the same phase, right? So different things could be refreshing or capturing at different times, and that would result in footage that doesn't look good. And so Genlock really just keeps everything at an even 24 FPS. And we do that mainly through NVIDIA QuadroSync, right? So the cards in the machines have this NVIDIA QuadroSync feature, and we set the we synchronize them in our case to a master clock. So there's something here basically telling all of the different machines to render at 24 FPS because that's what we're capturing and shooting at. This is how it ends up laying out, right? So we have a master clock. This is the thing that's basically the metronome. It's saying 24 FPS. It's telling it it's going to tell every machine to make sure to render or display at the same interval. And so the master clock really only needs to be connected to anything that's feeding the wall, right? So the primary machine and the 3 render machines are the ones that are connected through to the master clock, and they're the ones that are always hitting the same even 24 when they're feeding to the wall. The other machines, like the VR and Scout machines, it doesn't necessarily matter that they're rendering at the same interval because they're just making content adjustments likely. So this is kind of confusing, I have to admit. It's taken me a really long time to wrap my head around it personally. But I keep coming back to this kind of metronome idea, which is just that you want everything on 24 FPS because that's what we're shooting at. Another thing to point out here is the comp, right? So it may seem kind of counterintuitive that the comp isn't tied to this master clock. I mean, it potentially can be, but for the most part, the comp really only needs to be in sync with the camera feed. So it's receiving a video feed, and so it sort of ends up being separate from it because it just cares about the video feed it's getting. And so hopefully this video is going to explain the sync stuff a little bit better. This is something that we stare at a lot, right? So it's just a red bouncing ball, and it's just how we check sync, right? So as you remember, we have a seam in the middle with the way we've configured the wall, right? So we have a render box on 1, and we have a render box on 2 on the front wall. So we just set up this ball to bounce on the seam. In this case, the ball looks like a ball, right? It's very smooth, right? So we're saying sync is good. The counterpoint here is when it's not good, it looks like this, right? So it means that they're not the machines are not in the same sync, are not running at the same interval, right? So the metronome is off, and one machine is not. They're not rendering on the same frames, and so this is something that we also stared at a lot when we're learning about all of this stuff. So in this case, this would be tearing, and tearing is bad. And if especially on a case where you're panning across, you would get tearing, and you wouldn't get a final with something like this on there. So that's just something to be aware of. Another thing that we've done a lot is looked at the back of the machine. So you just want to see these green lights on the NVIDIA Quadro cards. The green light is good, and yeah, the green. That's sync. So this is latency. Another video that I didn't turn the audio up on. Sorry, but sort of full disclosure, there is a little bit of latency, right? So in order to get the all of the data through, there is a bit of lag. So you can see, as the operator pans back and forth, it's a little bit behind. So we've worked really hard to make this as low as possible. We have made a lot of improvements, but there's definitely more to come. And it's a big collaboration between essentially every link in the chain, right? So the LED teams and the processors, the cards that we're using, we want to get this as low as possible so that it's as responsive as possible for filmmakers. But there is a little bit of latency to be aware of. And we measure it with this very scientific process of taking a photo with our phone, showing time code on the wall through Unreal Engine, and the time code at readout on this little device. So we take a lot of these photos, and just sort of as a public service announcement, be careful when you're taking these photos on set. Oftentimes sets don't like it when you take photos on them. There's all these rules. Don't be like Andy. He took photos on set. He got in trouble. But he's really happy about it. We kept Andy. He's great. Anyways, what are we on now? iPad. So the iPad is a remote control app that we sort of wanted to give a lot of these like creative controls. Put something like more directly in the hand of the DP, the production designer, the gaffer, or the director himself. And so the idea here is that on stage, like, you may not have the actual desktop machine very close. Oftentimes the production teams just don't want that. And then there are a lot of frequently done operations that maybe they're too spread out, or maybe it's a little bit more too complicated to do in the editor. So we try to consolidate into this concept of a remote control app, and that uses a new plugin called Remote Control. This is basically a REST API that allows you to create like web-style apps that adjust parameters on anything in the scene. So we tried different approaches, like using OSC, and there's a bunch of other ways of approaching this, but ultimately we've kind of settled on this REST API idea, which has worked pretty well so far. First step is, or after you've enabled it, the next step is that you have to enable this console command, which is called web control. Apparently this comes from Fortnite Creative. But it's a step that you can easily overlook. It's going to become a project setting, I hope, in 424. But I just wanted to point it out because I know I got tripped up on it. I forgot when I first started using it. I forgot to turn it on and didn't know why it didn't work. And so don't be like me. The remote control is another thing that connects into this kind of ecosystem of multi-user. So if we go back to the diagram we had before with multi-user, we're now adding this remote control web server, which runs on the primary box. And so essentially the iPad will communicate directly to the primary box as if like somebody on the primary machine did it. And so that's how it gets into the multi-user session. So anything that the filmmaker changes on the iPad app is also reflected on the wall and all the other machines. So step through a couple of examples here. This is one of the tabs on the app, which is for stage manipulation. And it's one of the more simpler examples, and it's for like the director or the DP to like move the world, right? So they have the camera set up, but the stage itself isn't moving. So your way of moving around the world is you can just shift where you are in the 3D space. And so this is an iPad app where they can kind of move through space or rotate the world to get the right angle in camera without necessarily moving the camera. And so all it's doing here is pointing to an actor that's in the scene, which is this guy here. And really all it's doing is it's just moving these values, but through the iPad. So this is kind of a simpler example, but it's again something where through the REST API you're just modifying these parameters on the actor, and the result is something like this, right? So in this case, Colin's rotating the world here, right? So he's on the iPad, he's just rotating, figuring out which angle he wants to see there.
Because you can.
A more sophisticated example is this kind of sky switcher, right? So this is something that we've set up that allows the teams to like potentially change time of day. So they may dress a set to be a certain way, and then you may shoot different scenes there. You can make it sunset, for the entire shoot, or for the entire day. Say you don't have to worry about like the actual sun moving. So on the top, like you can kind of switch between different skies that you may have pre-selected and like, and there's other parameters there as well. Like these are like then like sort of put through a blueprint. It's like the same idea, right? Instead of being a simple actor that we're pointing to, in this case we've made a blueprint that exposes all of the controls. So again, it's basically just like a one-to-one match. So all of the stuff that you saw in the iPad are just directly controls here that through the REST API you can adjust. So the result is something like this, right? So this was one of our kind of demo shots where we showed just how you can swap time of day. And this is a dynamically lit scene in Unreal Engine. The sky is acting as an IBL. And it's just showing how the entire environment can change, but at the same time, it's also showing the different flexibility that you can get from the control app. A few more screens to show here, right? Like this is the templates page. This is for saving different. This is for basically saving different templates that you might like. So at the beginning of the day, the team might sort of plot out the different shots, right? So they can move things around, make the adjustments they want, save them, and then come back to them later in the day. These can also be recorded if you're using Take Recorder. There's the ability to make these kinds of adjustments like inside and outside of the frustum. Like once we started working with DPs, they had all these requests for the different kind of fine-tuned controls they wanted, right? So through the iPad, we've set it up so they have these types of controls. Like so sometimes like outside, they want to make it brighter to light the actor, but they don't want it in camera so much, or vice versa. It's just another example of like kind of the production efficiency we're trying to add through an app like this. As another public service announcement, apps like this actually generate quite a lot of data, so you just have to be careful from a network perspective. Like we recommend like having if you're doing an iPad app like this on set, like give it its own network. We've had many misfires where we didn't do that, and like the laggy iPad really doesn't fly very well with directors. Another thing to note is that you should also avoid putting it on the mocap or camera tracking network as well. It's just these are all like kind of do's and don'ts, but the mocap and the camera tracking, like it actually generates a lot of data, and so you've got other data that's kind of traveling, needs to travel on the same network. They can kind of get in each other's way. So I highly recommend giving the iPad app or any of your control apps their own network. All right, so the last bit we'll show here is the green screen, right? So on the screen page, we also have the ability to basically one-click get a green screen. So for the most part, we hope that people are able to, let's go back. So here's the video of turning a green screen on, right? So just with a simple click of the iPad, you can add green. You can also add tracking markers.
And then some sort of marker change.
And then you can also change the density or the thickness of these guys, right? So the idea here is that there are still going to be some cases where you need a green screen, like maybe the background doesn't look good enough for a particular shot, or maybe you're for various constraints you just aren't able to get a final. The idea here is that like when you're shooting with an LED wall in Unreal Engine and camera tracking, like it's still like adding a lot of efficiency in that way. It's like if you would have imagined a world where you were shooting on a set and you didn't have a green screen up, and then somebody had to come in and install one, it's certainly longer than one click. On a personal note, with the tracking markers, like it's really like sort of blows my mind, like that you can just set these things up. Like I've spent a lot of time. I don't know if anybody has ever done tracking markers, but like it takes a really long time. like sticking all of these tracking markers up, going on a scissor lift, taking them down. It's like it was a real moment for me personally when we first rolled this out, just because it would have taken a full afternoon to put the tracking markers up otherwise. Last bit on green screen is that we also have some live compositing features through Composure, and in this case, our Aja SDI input. So this is just us kind of testing around where we're moving the camera. Just a green screen frustum. The idea here is that we're still getting better lighting. We still have the environment capture on our stand-in. So there's less spill. He's still getting lit by his environment. You'd hopefully get a better green screen played out of it. And then you're also getting this preview comp. So Composure has a keying feature, and we also have SDI out to pass it back out. So this is another example of one of the virtual production features of Unreal Engine at work. And we'll kind of close with an outtake. So this this was a shot that we were just messing around with. We mostly shot with the physical motorcycle, but we also had a CG one. Like originally, we were gonna shoot like this walk-up shot to the CG motorcycle, and then sort of like that was like how we prevised it. And the way that this shot came up was you know, we were about to shoot it, and we forgot to add the motorcycle back into the scene. And so we had rigged it, and when we spawned it, it just dropped and it bounced. It had suspension, and so everybody thought it was funny. It just looked really it just looked really funny on the wall. And the actor was like, "What if I snap my fingers?" And we triggered it. So then everybody liked it, and we kind of workshopped it for a couple of minutes, and you know, that ended up being the shot. You know, and the takeaway for us is that like may seem small, but it's something that we're really excited about with virtual production. Like bringing these tools, like this is something that never would have happened if it was always all green, right? Like nobody would have ever thought to try that shot. And so like it was kind of like an interesting microcosm of the way people are working together with this technology, where, you know, it was a happy accident to some degree. We forgot to put it in, and then we dropped it in, and everybody thought it was funny, and now it's this shot. There it is. This is my dog. I took this picture of my dog. I was trying to find like a much more organic way to get this in, but I didn't have one. So this is my dog in front of an LED screen.
What's his name?
It's Maddie. It's a she. So it's, you know, at the very least, we'll work on our dog influencing through the LED walls too. That's my talk. Thank you. That's all I can think to say.